Today we're going to go over the two special right triangles. The first special right triangle is a 45 degree, 45 degree, 90 triangle. In a 45 degree, 45 degree, 90 triangle, two of the angles are the same, which means that two of the sides are also going to be the same. We have an isosceles right triangle. If this side is x long, this side is also x long, and our hypotenuse is longer than either leg. How much longer? Well, it turns out that the hypotenuse is exactly the square root of 2 times longer than the leg. Our second special right triangle is a 30 degree, 60 degree, 90 degree triangle. It has 3 different angles, so all 3 sides are going to be different lengths. The shortest side I'm going to label x. Our longest side is going to be the hypotenuse across from our 90 degree angle, and it's going to be twice as long as our shortest side. And our middle side is across from our middle angle, across from our 60 degree angle, is going to be longer than our shortest side, but shorter than our longest side. It's going to be right in the middle. So we're going to take our shortest side and we're going to multiply it by a number that has to be greater than 1 and less than 2. It turns out that that length is exactly the square root of 3. If we take these two concepts and apply them to our examples, in example 1, we have a 45 degree, 45 degree, 90 triangle. The two 45 degree angles tell me that I have 2 congruent sides. So side M is going to be 3. And side N, which is our hypotenuse, is going to be longer. How much longer? Well, it's going to be the square root of 2 times longer. Our second example is not drawn to scale. I always like to redraw these triangles to scale and orient them so they are like our examples. The hypotenuse in this case is 5 square roots of 2. Across from our 45 degree angle is n, and across from our other 45 degree angle is m. If we look at our hypotenuse, it's 5 times the square root of 2, which means that each leg has to be 5 if we follow our pattern. In example 3, our triangle is drawn to scale, but it's just oriented different than our example. I'm going to redraw this triangle so it's oriented like our pattern. Our hypotenuse is across from the 90 degree angle, and in this case is n. Across from our 30 degree angle is 13, and across from our 60 degree angle is m. So if we follow our pattern, we know the shortest side. We know the x side. To get to our hypotenuse, we're going to double our shortest side. To get to our middle side, we're going to take our shortest side and multiply by the square root of 3. In example 4, our triangle is not drawn to scale. So redraw that triangle to scale. Across from the 90 degree angle is 22. Across from our 30 degree angle is m, and across from our 60 degree angle is n. In this case, we know the hypotenuse. So if we go to our example, we know this side. To go from our hypotenuse to the shortest side, we need to divide by 2. So m in this case is half of 22, 11. Now we know our shortest side, and to get to our middle side, we're going to take our shortest side and multiply by the square root of 3.